Welcome to example number 5. This is a question to see if you understand how to take the different pieces of information that you have from a graph. So what we're showing here to the right is a position versus time graph. Sometimes I like to call this the history graph because it shows a historical picture of the position. So we have an object oscillating and we're asked to find a number of things here. Let's start off by looking at the picture and see what we can get. First thing is asking for the maximum displacement, which is the amplitude. So if you look at the graph here, how far does it go away from the equilibrium? So remember, this is the equilibrium position here, and the maximum distance it goes from above or below looks like it's 8 meters. So this is 8 meters. Okay, going on to part B. How long does it take to complete one cycle? So they're really asking for what is the period. So the period is the time it takes to make one complete cycle. So if we start right here at the beginning, it's nicely set up. It goes all the way here, and then now it's going to repeat the motion. So that's one entire cosine curve. So it looks like that. If we go from 0 and then drop all the way down to here, that looks like it's 4 seconds. Now you could solve it other ways too. You can sometimes it's not very clear on this graph, maybe just shift it a little bit to the left or a little to the right. So sometimes it's good to start from, say, here, this axis, and then go all the way again here. And so that would be 5 seconds minus 1 second, which gives you 4 seconds again. So you're just looking for 2 consecutive repeated points. C part, we're asked to find the angular frequency. Now the angular frequency is 2 pi times the regular frequency, or you could use 2 pi divided by the period. So that's 2 pi divided by 4. That gives you pi divided by 2 in rads per second. Okay, let's move on to part D now. At what times is the object at rest? Now you have to remember that that occurs when the object is at the maximum displacement. So really right here, or here, or here, or here. You could also think of it as it's where the slope is going to be 0, because the slope of a position time graph is going to be 0 when it's at the top or the bottom of these little hills. So our answer to D would be at t equals 0. Then the next time would be 2, and the next time would be 4. The next time would be 6, and it would continue on and on, multiples of 2 seconds. Okay, part E is asking for when is the object reaching its maximum speed. So at what times? T equals what? So now you're looking for when the line would be the steepest. And that's going to occur right here, or right here, or right here. So at these different locations. So that would be at t equals 1 second, or 3 seconds, or 5 seconds, and multiples of 2 from here, so etc. Okay, F. What is the equation of the graph for this picture that we're shown? So we need to write x as a function of time. So x is a function of time. This is more of a math question. You can see that the amplitude is 8, so we're going to have an 8. We can see it starts off, it's a cosine graph, so we'll have a cosine. And then we have, if you recall from earlier, it was omega t, which is the angular frequency times time. So this is really 8 times cosine, and omega was pi over 2 times t. So if you were to graph this as a function of time, that's what the equation you would need to put on your calculator. Okay, for the velocity as a function of time, well, technically this is more of a calculus question. Okay, that's the easiest way. Velocity is really dx by dt. It's the derivative of this function. And so if you were to differentiate that function, you would end up with basically the derivative of a cosine is negative sine. So it's going to be 8 times the derivative of the argument, which is pi over 2. And then sine, there's a negative in here, sine pi over 2 times t. So that's basically velocity as a function of time will be equal to negative 4 pi sine pi over 2t. I wouldn't ask you to do this in Physics B because this is calculus. So those of you who don't have calculus, you would have to basically remember the equation is negative omega a sine times omega t, and then substitute your values for omega, which is pi over 2, then multiply by your amplitude, which is 8, and then sine, and then pi over 2t. So you can write it either way using calculus or this way. And that's it for example number 5.